Yes. Yes, sir.
Okay. So today we are having the switching technologies of the one. We are starting the switch configuration today. This is the concept VLAN, then BTP, MLS. Okay, all these concepts we are discussing today. Okay, so uh, switches. We used switches, right? In the topology, what we have used in the routing section, there exactly we have used this switch, correct? This one, 2960-24 GT,
Yes, sir.
right? So all these models, what you are seeing of here, this one, it is a 2950, hyphen 24, 2950, 2950T, hyphen 24, 2960, 24T. All these are basically your layer 2 switches. And layer 2 switches simply means that all these switches, they can perform switching function only. Okay, only can perform switching only. Switching. Okay, can perform switching function only. Switching means taking frame like from one port and delivering it via one via another port. Okay, for example, you are having all these ports available. All these ports are available over here. You can see this is a how many port switch? 24 port.
24.
And this 24 port means how many machines we can connect in it?
24.
24 number of machines. Okay. So suppose your PC, okay, this is the port which is connected to your PC, and this is the port which is connected to another PC. So all these ports we are connecting via what? Via our NIC, right?
Yes, sir.
We have our NIC port available, and this ports we are using in order to connect to our switches, to our routers. Okay, but normally we're using these ports to connect to the switch. Okay, because that is our switching network what we are making. So whenever any of this system, let's say that this machine is sending any information to this machine, so the switch is taking the frame. Okay, those switches they send or receive frames. So when a switch port receives a frame, then it basically delivers it by another port over here, okay, to this particular machine over here. And for that forwarding purpose, it is using the source MAC and destination MAC information. These informations are found inside the layer 2 header of the frame, L2 header of the frame. Switch always considers this information for forwarding of your frames. Okay, whenever it receives a frame from any system, it basically checks the layer 2 header of the frame in order to find out who is the source and who is the destination. And based on that, it basically builds a table. And that is the table what we call what? So it builds what table? It's a Mac
Yeah.
or CAM, right?
Cam.
CAM table.
Cam.
And this Mac or CAM table contains what information? Port 2 MAC mapping. Port to MAC mapping. This is what exactly this particular MAC table it contains the information. So always whenever the switch takes any frame, it basically checks the layer to header information to find out who is the source and who is the destination. When it sees the destination MAC, this is when it contacts the MAC table in order to find out that which particular port is connected to this destination, and based on that, it performs unicast forwarding of frames. Unicast means what?
One-way communication.
One-to-one communication. So unicast forwarding. That is the reason we consider this particular switch as an intelligent device, because it takes all these informations in, in consideration in order to forward the frame to the correct destination. It is not like a hub device which forwards all the frames to everyone who is connected to the hub device, because hub always follows a broadcast approach. And broadcast simply means one to
Many. All.
one to
Only
all,
all.
one to all, not one to many. If it is one to many, then it will be
That will multicast. Yes.
multicast. So all these switches, okay, this switch models, what you are seeing over here under L2, all these switch models they basically perform their switching function in this manner. But there is also another type of switch, what we consider as a multi-phase switch. We call it L3 switch. Now, why we are calling it multi-layer or L3 switch? Because this switch can perform the base function of all the switches. That is, the switching can perform switching function as well as routing function as well. Routing function. So can perform switching function as well as routing function. This is what exactly is the reason we are calling it multi-phase switch. Means it works at the L2 level, that is your data link layer, as well as it works at the L3 level as well. Okay, so both layers functions exactly it is performing. That is the reason we call this particular switch as an multi-layer switch, as an L3 switch. So always this type of switches, it's a little bit costly. It's a little bit costly compared to this type of switches, this type of L2 switches. Why? Because when you have more functionalities included in a particular switch, always the cost is getting higher. So more functionalities means more cost. Okay, less functionalities means lesser cost. This is how exactly these devices they are basically priced. Okay. So when we are purchasing this type of devices, we can only perform switching function. But when we purchase layer 3 switch or multi-layer switch, then all the functionalities of layer 2 switch you will be getting in this multi-layer switch. As well as this multi-layer switch can also work like a router. Means if I use this device, then I don't basically require a router to perform routing, because this switch can also perform routing. It simply means that you can run EHFP, REAP, OSPF, static routing, everything you can do it on this particular multi-layer switch. So it saves cost. Okay, it saves cost of a router, because when you are using a multi-layer switch, you don't need a router device. But remember one thing, that router is your dedicated device for doing routing purpose. There are lots of functionalities what we do on a router and what is supported on a router, but not on a multi-layer switch. Okay, that is why exactly in organizations both routers and switches will be seen. Okay, you'll find it. But if any um, organization, they basically don't want to use a router, then they're basically using a multi switch and they're performing routing as well. So both circumstances, both scenarios are available in the organization. Okay, where exactly they're doing all the functionalities of your routers. Okay, with a dedicated router they're using on the network, or you may find that they're using multi switch, where they're doing the routing function with the switch itself. So both functionalities are there in your multi switches. So this is the model of the multi switch 3560 20-24 PS. You can find it over here. This is the model 3560 24 PS. Okay. And all these switches, we are basically layer 2 switches, means they cannot perform routing. Okay, you cannot configure routing protocols in these switches. Now, when we are discussing about switches, everyone, all these ports,
Sir,
uh,
sir, your voice is coming bit low, and even glitches are also there, sir.
okay, just hold on.
Yes, sir.
Okay, can you hear me now?
Yes, sir. Now it's clear.
Okay. So what exactly I was saying over here is all these are your layer 2 switches. Layer 2 switches. They are basically used for performing switching function only. And these are your multi-layer switches, which are basically used for performing switching as well as routing function only. And when you use a multi-layer switch, this switch can also like what can also support performing routing, okay, or routing commands, okay, what we use in our IPs to get out and all these things, similar like your router. Okay, so if you uh, need a router to perform routing, then you don't basically uh, you don't have to have a router to perform routing. Your multi-layer switch can also support that. That is the reason we are basically using multi-layer switches in our organization. Regarding those ports, everyone, all these ports, what you were saying, is a 24 port switch. Okay. Regardless of whichever port your machine is connected to. Okay. So if you connect your machine, you can see the port number is there 1, 2, 3, 4, 5, 6. All okay, all the ports in your switch, okay. It basically starts with 0/1. Okay. This is the port number. Okay. We have all these ports are first run out of types. Hence, all the ports they have capacity of transmitting information at 100 Mbps speed. All ports are basically your 100 Mbps in terms of speed, and it starts from 0/1. Okay, always switch ports they start from 0/1. If we consider it okay, the same number of ports in routers, then it starts with on the router it starts with FS0/0. Then it looks like FS0/1. Okay, like that. Then if you add modules in your router, then it will be like FA1/0, like that. FA1/1. It will be like this. Okay. But always it starts with FA0/0. So this 0/0 port you can find it in your router. But you never find this port in your switches because switch always starts from 0/1. This is your port number 1 port, and this is the port number 24. This one. So suppose you have connected your PC to port number 1 and you have connected another PC to port number 24. By default, this machine, this PC, will communicate to this PC. It simply means that regardless of whichever port you are connecting, let's say that you have connected another machine to PC, okay, to this particular port. So every single machine, they will be able to communicate with each other. Okay, means full communication will be there regardless of whichever port you are connecting. Okay, so what is the reason all these ports they are communicating with each other? Means this port will communicate with this port will communicate with this port. Any port can communicate with any port. Okay. Now the base reason for which this communication is happening, it is because they belong to the same broadcast domain. They belong to the same broadcast domain. Okay. That is what we call single broadcast domain. Okay. Just think of it like that all the ports they belong to the same network. At the layer 3 level, we call it a network. Okay. Like a LAN. In a LAN, when you have multiple machines, they're part of that LAN, every machine can communicate with everyone. Like in LAN number one, we have seen that we had a switch and we have connected our PCs, our laptops, our gateways in that LAN by that switch. And by configuring IP address, they started to do communication. Without any configuration on the switch itself, they were doing communication. Right. So this is what exactly is happening when you have a switch in the middle. Okay, because it allows the communication to all the machines, whichever is like or whichever machines are connected to all these ports. Okay, every port can communicate with every port, and we simply just call it single broadcast domain. Okay, just you can compare it with the concept of network. Okay, with the concept of LAN. At the layer 3 level, we are calling it LAN. At the layer 2 level, we call it broadcast domain. So when multiple machines belong to the same broadcast domain, this is when exactly they basically belong to a single network, okay, at the layer 3 level, and they can make communication with each other without any problem. You simply just configure IP address in these machines and they will be communicating. So what exactly I'm trying to say over here, let's understand it with the help of an example. Let's say that we have two machines. Okay, this is your laptop. So these two machines, we are simply just connecting with the help of a switch. So take any switch, whether it is a multi-layer switch or it's a layer 2 switch, it doesn't matter. But as long as it's a switch, always you'll see that you don't have to configure the switches. Just configure the IP address on these machines, and these two machines, they will be able to communicate with each other without any problem. So you can see that the port number, it is starting with FS0/1 because we don't have an FS0/0 port. The 0/0 port, you can basically find it if you are using a router. So if we are using a router over here, then on the router, you can find this port 0/0. See that. But on the switch, this port is not available. Okay. So this is how exactly you can make a differentiation port-wise. That on the port-wise, you don't get FS0/0 port on your switches, but on the router, it basically starts from first ethernet 0/0 itself. So let's simply just connect our machine over here to this port and this port 0/2. So simply by connecting, this is our LAN which we have created. So let's say that this is the LAN number one, and we are having an ID of LAN one which is 100.0/24, and we are giving 100.2 over here and 100.3 over here. Okay, these are the two IP addresses. We're simply just configuring these two machines with these IPs 100.2 and 100.3. So this is your 192.168.100.3. That's it. And since we have just configured IP addresses without doing any configuration on the switch itself, you can see, okay, that this machine is communicating with this one if we send a ping over here. So ping 192.168.100.3. And you can see that reply is coming automatically. Now, why this reply is coming? It is because of the reason that this particular machine this particular machine, this one is connected to port number 1, and this machine is connected to port number 2. Okay, and by default, these ports, they basically belong to the same broadcast domain. Okay, so all the ports belong to the same broadcast domain. That is why exactly this machine, these two machines, they were being able to communicate with each other. Okay. It is simply just like at the layer 3 level, these machines belong to the same network, and they're making communication with each other, even without doing any configuration. Okay. So single broadcast domain, this is what exactly you are getting in a switch. Every single port. If it's a 24 port switch, if it's a 24 port switch, then all the 24 ports belongs to the same broadcast domain. If it's a 48 port switch, and all the 48 ports which also belongs to the same broadcast domain, means any port you can connect your machine to in the 24 or 48 port switch, always you will see that they are communicating with each other. Okay. Now this type of behavior of switch allowing communication between systems regardless of whichever port you are connecting to, it's a problem in the organization. Okay, because if you see over here in the organization, always we are having certain like what policies, certain requirements are there. And what exactly is the requirement? Is the department requirement. Okay, departments. Okay, because companies always they form, okay, always they have a department structure. And this department means what? Like they have sales department, they have finance department, they have HR department. All these departments they are having machines. And they have a policy that one department should not be communicating with another department. Sales department machines should not communicate with the HR department. Finance department machines should not communicate with marketing department. Okay, all this type of requirements always is there. So when we are using a switch and we have this type of requirement in the organization, then like what? There is a problem. Okay, coming in because when a machine from sales department we are connecting to a switch, and on the same switch we are connecting another machine from HR department, then by default the communication will be allowed. Okay, it will be allowed from this machine to this machine because both the machines they belong to the same broadcast domain. That is why exactly they will be able to communicate with each other. What the organization they don't want. Okay, the organization doesn't want machines from one department to communicate with another department. But when we are connecting a switch, this communication will happen by default. Okay, because every single port it basically belongs to the same broadcast domain. That is the reason. So how exactly we can divide this communication? Okay, because the division must be there in terms of communication between all these departments. So when multiple machines from different departments getting connected to the same switch, this communication will be happening. Okay, and this is what exactly the organization doesn't want. So this is the reason what exactly we are doing it is we are using VLAN concept. Okay, so VLAN concept we are using that is basically it stands for virtual local area network. We're using it to divide the broadcast domain. Okay, you can see that divide one single broadcast domain, and we're creating multiple broadcast domains. So what we are seeing in this topology is one single broadcast domain which is represented by this circle. Okay, so this is one big broadcast domain. We are basically dividing it. Okay, we're dividing it into smaller broadcast domain. As you can see, this particular box is represented the broadcast domains. Okay, so when a broadcast domain is getting divided into smaller broadcast domains, then from this broadcast domain, this machine cannot communicate with this machine. Okay, because VLAN doesn't allow, or your switch doesn't allow communication between two broadcast domains. Okay, by default. So communication is getting divided. Communication is getting separated when you are using when you are using this type of VLAN concept. Okay, so you can see that we are using some type of numbers over here. These numbers of VLANs, these are basically called as VLAN IDs. So VLAN IDs are nothing but simply just identifiers, what we are using to recognize a VLAN within a switch, or for the switch to differentiate that this is a separate broadcast domain, this is a separate broadcast domain. This is the identifier which basically helps switches in order to differentiate between two different broadcast domains. Okay, if multiple machines belongs to VLAN 200, then both the machines can communicate because they belong to the same broadcast domain. But if another machine belongs to VLAN 300, then from VLAN 200 to 300, communication will not happen because of their broadcast domain is separated, okay, or it is different. So there are certain VLANs which we are considering default VLANs again. Okay, just think of it like this: that every single VLAN represents like what broadcast domains in a switch. Okay, means if you have one VLAN, it means what you have one broadcast domain in your switch. If you have 10 VLANs, then it means you have how many broadcast domains?
10
10
broadcast,
broadcast domains.
10
If you
broadcast,
have 100 VLANs in your switch, it means what?
100
100
broadcast.
broadcast domains. Okay. So within a broadcast domain, you can have multiple machines. Okay. Right now, I am having only one machine, but you can have hundreds, even thousands of machines in a particular, like what VLAN. Okay. It is totally acceptable and it is allowed as well. Okay. So all the machines in a particular VLAN, they can communicate with each other without any problem because they belong to the same broadcast domain. But when it comes to communicate, okay, to another machine in another VLAN, this is when the problem comes because communication will not happen. Switch will not allow that communication between two different broadcast domains. So this is the concept. What exactly is saying for your layer 2 switches as well as layer 3 switches. As long as it's a switch, you always have the VLAN concept. Switch cannot work without a VLAN. Okay, always it needs a VLAN. That is why exactly this default VLANs like one by default it is there in a layer 2 switch as well as in a multi-layer switch as well. These are the VLAN numbers. What exactly is created during the manufacturing of these switches. So VLAN number 1002, 2005. These are the 5 VLANs. What exactly is created when a switch is getting manufactured. Okay. So VLAN number 1 is the default VLAN. Okay. Then VLAN number 1002, 2005. So total 5 VLANs you have accessed. Okay. You have 5 VLANs by default. 5 VLANs. By default is this in every single switches. Okay. And all the ports is your multi switch. All the ports on your switch, it basically belongs to VLAN number 1. It belongs to a particular broadcast domain. Okay. So since your machine, when you connect to this port and this port, since both the machines belongs to the same broadcast domain, that is your VLAN number 1, okay, these machines they can communicate without any problem because they basically belong to the same broadcast domain. This is the VLAN number 1 by which all the ports on your switch is assigned. Okay, always ports are members of VLANs, everyone. Ports always take the membership of VLAN. Okay, and this membership of VLAN 1 is by default given when a switch is manufactured. Okay, so that is the reason this type of communication is allowed. No matter whichever port we are connecting our machines to, always this communication will happen because all the ports in the switch by default it belongs to VLAN number 1. These are default VLANs. Now, always we don't want to use the default VLANs. That is why exactly Cisco has given us this particular range of VLANs, which we can use to meet this type of requirements in the organization. Okay. So these are basically called the normal VLAN range. We have 2001. This many number of VLANs we can create within a layer 2 switch or within a multi-layer switch. So always, whenever you need to create a new VLAN, always you can take any ID from this particular range and you can create your VLANs in your company switch. Okay. So these are the VLANs what exactly we are also using. You can see VLAN number 200, VLAN number 300. All this 200 300 is coming in between this range. Okay. So within 200, we are having sales department. We have HR department. You can see the network ID 194.100.0. From this network, we are giving 194.100.10 to this machine, and 195.100.0 from this network. We are giving 195.100.11 to this machine. Okay. So when a broadcast domain is different, we also make our layer 3 address also is different. Okay, because there is no point of keeping the same broadcast domain or having a different like what network id, or having the same network id and making different broadcast domain. Always when we create a new broadcast domain, okay, or a VLAN, this one exactly we give the different network address as well. Okay, so different VLAN, different network address. Okay, at the layer 2 level, at the layer 3 level, we are simply just um, keeping them okay the same, the address okay the same over here. So this one belongs to 194 network and this one belongs to 195 network. As you can see, the network address is different, the VLAN ID is different. This is the way you are basically uh, going to see the company's switching network. Okay, in this manner, they are basically configuring their switching network. So what exactly are the configurations? What you do in order to create these VLANs? Okay, so I'm having the notepad file available, which you can basically take the screenshot for. So let me just load the configuration. It is your switching config. Okay. Now this configuration, what exactly we are going to be discussing over here, it is applicable for multi-layer switch as well as your layer 2 switches. Means regardless of whether you are using layer 2 switch or your multi-layer switch, the process of creating VLAN is basically same. Okay. What exactly you do is you say the VLAN command from your global configuration mode and you say the VLAN ID. Okay, so VLAN then VLAN ID. So we are creating all these VLAN configurations in the multi-layer switch. However, if it's a layer 2 switch also, you can do the same configuration. It will work. So we have two VLANs, 200 and 300. So we are creating it first. Okay. So creating the VLAN configuration wise, two things always you do it. Okay. When you were doing VLAN configuration, first of all, you have to create the VLAN, create VLAN. Okay, on your switch, this is the first thing. And second of all, assign VLAN to ports. Okay, because this is the ports which are connected to your laptop, desktop, servers, and all these routers. So always we assign the VLAN to the ports. This is mandatory. Okay, if you are simply just creating the VLAN and you are not assigning the VLANs to the ports, it means what? It means broadcast domain will be created, but it will not be applied to the port. Okay, so it will not be operational on the ports. So that is the reason always two steps you have to follow. Okay, this step over here, it is for creating the VLAN. Okay, to create the VLAN, and this step, what exactly we're seeing over here on the interface level, this step is to assign the VLAN to the port. Okay, so two steps always. So creating the VLAN and assigning the VLAN to the ports. So first of all, you can see VLAN 300 name is HR department we are having here. So this is the HR department. Then exit. Then VLAN 200, that is your sales department, and exit. Okay. So once you have created the VLAN, next you have to apply the VLAN to the ports. So this is when you have to note down the port numbers. So this is the port FS0/1 which is connected to this particular VLAN, and this is the port which is connected to this VLAN. So we are going to 0/1. We are giving switch port mode access and switch port access VLAN. This is the command by which you assign the ports to a particular VLAN. Okay, always ports belongs to a VLAN. Remember this. Okay, always port gets the membership of a VLAN. Okay, just think of it like this. The membership of a VLAN needs to be given to a port in order for the in order to identify that which particular port exactly belongs to VLAN 200 or which particular port belongs to VLAN 300, because this is how a switch makes the differentiation between two different ports receiving frame, okay, from like what different machines using VLAN concept. So FS0/2 is connected to your VLAN 300. So we are saying switchboard mode access, switchboard will access VLAN 300. Because you can see that this particular command is same in both these cases. Okay, always. Whenever you need to assign a particular port to a VLAN, this is when you always give switchboard mode access command. As switchboard access VLAN, then the VLAN ID. Okay, so if it is 200, then you say 200. If it is 300, you say 300, like that. Okay. Now, once you do this configuration, these two machines will not be able to communicate with each other because they belong to different broadcast domains. The VLAN 200 broadcast domain and VLAN 300 broadcast domain, and by default, switch doesn't allow that communication. So, what if we want to do communication? For example, what if I want to communicate from my VLAN 200 machines to VLAN 300 machine? Okay, because in organization, this type of requirement is also there. Okay, suppose this particular machine, there is a machine which is connected to this switch as well, and this machine, it belongs to manager. Okay, so this machine should be having access to both the departments. Okay, so since like what, this machine also will belong to a different VLAN. Let's say it is VLAN number 400. Okay, VLAN number. So in this particular case, that communication from VLAN 400 to all these VLANs, it should be allowed, because it's the manager of the organization who must have access to all these machines in this department. Suppose he needs some files from sales department. Suppose like what, some documents, important documents are stored in the HR department machine, and like what, the manager wants to see that. But, so from this machine, we should be having that that communication to this VLAN 200 and 300 machines. So this is when exactly we perform inter-VLAN routing. Okay, inter-VLAN routing means communication between different VLANs. In other words, we call it routing between VLANs. Okay. Now, when it comes to routing, your multi-layer switch can perform that. However, your layer 2 switch cannot do that. Your layer 2 switch doesn't perform routing function. Okay. This routing function, you can activate it within your multi-layer switch with this particular command. Okay. So this is the command to activate the routing function. Okay. Activates routing in your multi-layer switch. So if you want to do routing within your multi-layer switch, you can say IP routing. If you don't want to do, you can simply just say no IP routing, which will deactivate the routing function within your multi-layer switch. Okay. But in this particular case, it is required, because whenever we want to communicate from one single system which belongs to a single broadcast domain to another system, this is when exactly this routing is mandatory, without which you cannot perform that communication. So this two things, what exactly we need to do in order to perform this inter-VLAN routing configuration. Okay. First of all, we need to create something called layer 3 VLAN interface. This layer 3 VLAN interface is the interface by which exactly this multi-layer switch they perform routing. Okay, they cannot perform routing with the layer 2 VLAN information. These are layer 2 VLAN informations. Okay, and these two, like what, VLAN informations are available at the layer 2 level, that is your data link layer level. But whenever we are working with inter-VLAN routing, okay, this is when exactly you need IP address, because routing, it involves IP. Okay, IP addressing information to perform routing. Okay, the packets, what exactly our PCs will be sending from VLAN 200 to 300, it needs to be routed. Okay, and since routing is the function of your router, because it works directly at the network layer, that is your L3. This is when this interface VLAN 200 and 300, it is basically required. Okay, normally you are configuring your interfaces like this interface FS0/0 in your router, FS0/1 like that, and you configure IP address no shutdown. That is the same process. What exactly we are also using in order to configure our layer 3 VLAN interface. So this two VLAN interface we are basically creating from these two networks. You can see that. And for VLAN 200 interface, we are using 194.100.254. This is the address coming from here. And for VLAN 300, we are using an address from VLAN 300 network, 195.100.254. Now, why exactly we are creating this VLAN 200 and 300 interface? So that like what our multi switch can perform the routing function using IP addresses. Okay. So very easy command, what exactly you are having. You simply say interface, then you are creating layer 3 VLAN for VLAN 200 and 300. So you are simply just writing that. Then you are writing the IP address, okay, and subnet mask and no shutdown. That's it. Once you are done with this configuration, this is when your multi switch will be able to communicate, okay, or will be able to perform inter-VLAN routing, okay, between these two different VLANs. Okay, means machines from this particular VLAN, they will be able to communicate to this particular VLAN without any problem. Okay, so I have already done this configuration. Okay, and let me just show you the result, the ultimate result. What exactly you will be getting once you do this configuration. You can see that this is the address what exactly we are using as our gateway address for VLAN 200. So this address is coming from here. And if you see this machine, then this machine's gateway address is coming over here from VLAN 300 interface. You can see 195.100.54. It is basically this address. Okay, so what exactly is the reason we are creating the layer 3 VLAN interface? One reason is to perform inter-VLAN routing. Okay, because whenever your material switch receives any particular packet, okay, from your laptop one, this is when exactly it needs to check the routing table in order to perform routing. And routing table, it's all about IP addressing information, because via IP address only we are performing routing itself. And this address of 195.100.254, we are using it to basically send our informations to the gateway. So this address is working as a gateway address. This two interface what we are creating, these are basically the gateway address what our client machine from VLAN 200 and 300 will be using to send their information to other VLANs. Okay, so just think of it like the two different LANs. Okay, when we have used our routing topology, over there we have used our gateway address. LAN number one, gateway one was the gateway one's address we were configuring in laptops, PCs, and everywhere. In LAN number 4, we were configuring gateway 2's address in servers. But over here, this is the VLAN 200 and 300 interface IP address, which is configured as a gateway address to both VLAN 200 and 300 machines. Okay, so when you are creating layer 3 VLAN interface, this is ultimately you are creating a gateway for your VLAN 200 and 300 machines. Because if they want to communicate from here to here, this is when exactly they reside on their gateway addresses to basically make the communication. That is the reason we are creating the gateway addresses over here, okay, in the form of layer 3 VLAN interface. So two reasons: one is for performing routing between two different VLANs by multi switch, and second, to have a gateway address for your VLAN 200 and 300 machines, so that they can basically send their informations to the appropriate gateway address, and the multi switch can basically perform routing. Okay, this is what exactly is the reason we are having these configurations. So if I send a ping from my big laptop 1 machine to this laptop 2, in VLAN 300, that is our 195.1.11, you should be seeing communication is happening without any problem. So can you see the communication? The reply is coming.
Yes, sir.
So all these are your replies. What exactly we are getting over here? Now, if I do a trace route, trace route 195.1.11. So you will be seeing that this machine basically belongs to VLAN number 300, VLAN 300. Okay. So this machine will be sending its packets to our gateway address. So that is your VLAN 300 gateway. That is your gateway. And the gateway address is 195.1.1.54. That is our gateway address. And from the gateway address, it will be forwarded to 195.1.1.54. Okay, so it will be 194, not 195. 194. Okay. You're communicating from where? The laptop one, right? This is your VLAN 200.
Yes, yes.
Not VLAN 300. This is your VLAN 200 machine, which will be forwarding its packets to VLAN 300 VLAN 200 gateway. This is your VLAN 200 gateway. 200 gateway, which is 194.1.254, and from VLAN 200 gateway, it will be forwarded to 195.1.11. 11. So 11. So 195.1.11. Okay, so in this manner exactly, we should be seeing the trace route. So let's send it. Okay.
Yes, sir.
So can you see the VLAN 200? This is your VLAN 200 gateway, right?
Yes, sir.
The VLAN 200, which is the gateway. And when the gateway is receiving this packet, then it is getting forwarded to which one? The VLAN
Yeah.
300 machine, which is what? Laptop 2,
Laptop
right?
Laptop.
Laptop 2. Okay. This is how exactly it is getting forwarded, everyone. Okay. So from our 194 network, it is going to 195 network via our multi-layer switch. Okay, multi-layer switch, that is your MLS. And this particular multi-layer switch is performing because we have activated IP routing function in the multi-layer switch. So this switch is performing the routing by its routing table and simply like what? Forwarding the packet to the destination. So if you want to see the routing table of your multi-layer switch, everyone, you can simply just go to CLI and give the same command what you used to give in router, that is the show IP route. Command wise, there is no change. This is the like what flexibility of Cisco devices, everyone. Whether it is a multi-layer switch or whether it is a layer 2 switch, whether it is your router. Okay, command wise, everything is almost same. Like you have the enable command, you have the config key, everything it is same. So show IP route, we are giving the command, and can you see the routing table, which is having both the networks connected, right? The
Yes, sir.
194, 195 is directly connected, and this is the VLAN 200. That is your layer 3 VLAN interface, right?
Yes.
Interface. And this is your layer 3 VLAN interface. Okay, both this are your layer 3 VLAN interface for VLAN 200 and 300 machine. And when anything comes in this interface, then your multi-layer switch, it is performing routing and it is delivering it to this interface, okay, to the destination. This is what exactly you are doing. Okay. So configuration wise, very simple, straightforward configurations you are having. Simply just take the screenshot of this. One thing always remember that this particular section, it is same. Okay, this section, it is same for both of your switches. Okay, like if it is a multi-layer switch also, you basically have the same configuration. If you are using any layer 2 switches, like from this configuration remains same. Okay, so differentiation wise, in terms of configuration, changes starts from here. Okay, specifically this part. Okay, you can also do this configuration. Okay, on your layer 2 switches as well. But the thing is, this particular thing is not supported. Okay, this is the section which specifically is supported in multi-layer switch. So in a layer 2 switch, you cannot activate IP routing because your layer 2 switch doesn't work at the layer 3 level to perform routing between VLANs. Your multi-layer switch allows that communication. That is why exactly this one is specifically supported in any multi-layer switches. Okay. So all of you have taken the screenshot, right? Everyone?
Yes.
Yes.
Yes,
Okay,
sir.
so couple of
Sir.
things, what exactly we have discussed. First of all, how to create VLAN. This is how you create your VLAN. You say VLAN 200, 300, then how to give it a name. This is how you give it a name to your VLAN. Then how to assign your VLAN to your ports. Then this is the way to assign the ports to the VLANs, to the assign the ports to the VLAN. That is correct. Okay, this is the way. Then how to create your layer 3 VLAN interface. This is the way to create layer 3 VLAN interface. And how to activate routing. So a couple of things what we have discussed in this particular VLAN configuration. Okay. Remember each and every single thing properly. Now, since we are having machines, everyone, okay, since we are having machines in every single VLAN, these machines, it can be like what, one machine or it can be hundreds of machines, but all these machines requires an IP address. In order to do communication, always it requires this informations. Okay, so we have an option that we can give our VLAN 200, 300 machines of the IP address by DHCP as well. Because statically, when you were configuring it, if it is lower number of machines, then it is good. But if it is large number of machines in a VLAN, then you have to go for DHCP. So the question over here is how do you give your IP addresses in a VLAN environment via DHCP? So in a multi-layer switch, you can basically do that. Okay. This is also another reason we are using multi-layer switches. Okay. That this type of switches, it can also work like a DHCP server as well. Okay. DHCP server. So normally the configuration, what exactly we have done in regarding DHCP, we have done it on a router, right? Yes or no?
Yes, sir.
On a router, you have created tools and all these things you have done it in DHCP configuration. And we also have seen that we were getting IP addresses. The same configuration you can do on your multi-layer switch as well. And you can basically achieve the same result. But this time it will be like what in the VLAN environment, will be assigning IP addresses from this network 195 and 194 networks. Okay, IP addresses to these machines which belongs to VLAN 200 and 300. So how do you do that? Okay, how do you do this type of DHCP configurations? First of all, I'm also having this DHCP configuration available over here. So MLS with DHCP, you can see. Okay, however, this IP addresses we are using different, okay, from different network topology, but the concept is same. You create tools, you basically configure the networks, okay, for the VLAN in the port. You basically define your gateway addresses, your DNS server addresses, all this like what it is coming in the full configuration. And lastly, you just exclude those addresses which you don't want to give to your VLAN clients. So if I am just like what configuring DHCP in this particular multi-layer switch over here. So right now, this switch we are making as a DHCP server. Okay, DHCP server. So this is what exactly is the configuration, what I'm about to do. First of all, I will go to config T and we'll say IPTSP pool and we'll say VLAN 200 pool. That's it. Okay. So this is the pool what we are creating for our VLAN 200 machines. Then we say network address 194.100.100.0. The subnet mask is /24 we are giving. Then default router that is 194.100.100.254. This is the VLAN 200 gateway address. You can see it is coming. Then if you have a DNS server in VLAN 200, you can basically say it. I don't have it, so I'm simply just giving the gateway address over here as a DNS server address. And lastly, we are saying it. Okay, so this is very simple configuration. We are doing it. Then IPTC pool, we are creating VLAN 300 pool for VLAN 300 clients. Then define the network from which you want to give IP address to your VLAN 300 clients. So this is /24, the default gateway address that is 195.154, and the DNS server that is your 195.100.54. Okay, so let's just say exit. That's it. And lastly, we are simply just excluding those addresses which you don't want to give to our machines. So excluded address points 194, that is our gateway, and 195, that is our gateway. These two addresses we are simply just excluding it. So if you see the configuration, this is what exactly the configuration it really looks like. Simply just take a screenshot of this configuration.
Done, sir.
You can write.
Yes, sir.
Okay. So we are excluding our gateway addresses from this network. Okay. So whenever DCP will be assigning IP address to our VLAN 200 300 machines, these two address we are excluding it. We are not giving this two address to any of the clients. So right now it is about time to test the configuration. So simply just go to your VLAN 200 client and select the DCP, and we should be getting our IP address. See that? Okay. So we are getting our IP address from 194 network. Okay. And this is our gateway address, DNS server, everything looks correct. And from here, let's select the DSCP. But remember that this one belongs to 195 network. So we should be getting IP address from 195. And we are getting it. You can see that. Okay, so right now the communication should be happening. Okay, so from here we are pinging the 194.1.1.10. That is our laptop one. Which, oh, sorry, 194.1.1.1, right? Because this machine IP is changed, I guess. This 1.1.1. So let's ping it. We should be able to communicate because interval routing is going on. Are we communicating?
Yes, sir.
Yes, sir.
So this is what exactly we're getting. This is your MLS with DSCP, everyone. Your multi-gate switch MLS with DSCP. Okay, this is the configuration. Okay. Now, besides that, we also perform routing as well. Okay, we perform routing directly in a multi-gate switch. Okay, so let's consider this particular situation. Let's change the topology a little bit. So this is our router coming in now. Okay, so our router, it belongs to a network. So let me just connect this switch over here. So this is our router, and in between this we have a network now. So here we have the network address, let's say 196.100.0/24. Here we are giving 1.1 and we have 1.2. Okay, so In your router, you have to configure IP address. You have to make sure that the port is up. Okay, it should be up. Because switch on the switch side, okay, the port is always on, everyone. Remember this. Okay, whenever you are connecting any machine to any switch port, always the port will be on. It is on. All ports are on. You are not seeing this one as green. Why it is not green? Because this side, it is not up. Okay, this side is down. That is why exactly we're not seeing this one as green. But as soon as I basically give the no shutdown command on this port, you will see that this port is coming up. Automatically it will come up. Okay, because all ports in your switch is by default, it is on. Okay, all the ports. So no matter whichever switch you are using, okay, all ports, it is by default, it is on. Means you don't have to give no shutdown command. No shutdown. It is not required. Okay. However, if you want to shut down a port, you can basically shut it down manually. Okay, but all the ports on your switch are by default on. So that is the reason when you were simply just giving no shutdown on your router side, you will see that the switch port is also coming up. As you can see that all these ports are already green, means they are already working active. The thing over here is how do we configure a layer 3 IP address on a port which is connected to switch? Because this particular port, it is a layer 2 port. It's an L2. Okay, L2 port means it's a switch. And by default, this layer 2 port FS0/3 of the switch will not allow any layer 3 IP address on it. Okay, means this port is right now functioning at the layer 2 level. Means it is functioning in order to send or receive frames of informations. However, whenever you are trying to send packets of informations via this port, then exactly it requires an IP address, and this particular port doesn't support IP address at this level. Okay, so what exactly we need to do in order to configure an IP address to this port is we have to convert this layer 2 port to a layer 3 port. Okay. Unless we convert this port into a layer 3 port, this IP address we cannot give it. Okay. Always you will be seeing an error is coming. Okay. And the error, what exactly we're getting is like what? Invalid input detected. Okay. This is the error what you get. When you try to configure invalid input detected. Okay. This is the error what you face when you are trying to give an IP address directly at the layer 2 port of a switch. Okay. So this multi switch supports like what? Routing function supports the layer 3, that is your IP address configurations, but by default it is not activated. Okay. It is not activated to work as a layer 3 port. That is why we need to do the conversion. Okay, and the conversion always is done using no switch port command. When you give no switch port, this command, this is when exactly your layer 2 port, which is a switch port, it is getting converted to a layer 3 port. And when it is converted to a layer 3 port, then this port will take the IP address what you are about to configure on it. And it will not show this type of error. Okay. So this is what exactly we are going to be configuring over here. So starting with the router configuration, everyone. This is the router which is having first Ethernet 0/0 port. We are doing the configuration. So the host name is router 2, and we are configuring interface of 0/0 with an IP address of 196.1.1. Subnet mask is this, no shutdown. So basic simple configuration, what exactly we're doing regarding your router. The same thing one we are going to do over here. So let me just copy this command again, okay, to show you that command wise there is no problem. Okay, there is nothing wrong in the commands. When you give the same command in the switch under this port, okay, this is the port FS0/3 interface FS0/3, and if I simply just paste this command over here, that is your IP address, you will see this error. See that? Okay, so have I typed the command wrong? Is there anything wrong with the command?
No, sir.
It's no, right?
Yes, sir.
It is because this particular port right now it is working at the L2 level. Okay, it is working at L2 level. Means it is performing. It is used to send and receive frames. It is not used to send and receive packets to perform routing. So what exactly we need to do? We need to convert this particular port over here from its layer 2 level functionality to layer 3 level functionality, so that like what this particular port can perform routing, okay, can support IP addressing information. So this is the reason we are basically using the no switch port command. Switch. The no switch port command, what exactly we're using is to convert the port from layer 2 to layer 3, and you can see the line protocol is going down, and after that it is coming up. Okay, so right now you can see the port is green, and we should be able to communicate after configuring IP address to router 2, I guess. So let me just paste the same command over here again. So 196.1.1. Now this is the wrong IP what I have configured, because over here also we have configured the same IP address.
Yes.
That is just to show you that the same command exactly you can use. The way you have configured your IP address right on your router, and you have deleted the IP address, the same command is also applicable over here. Okay, so you can say no IP address to delete the IP address from the interface in which you have configured it by mistake. You can simply do the correction over here, and that's it. No shutdown, we don't have to give. If you want to give, that is also okay. If you want to give, okay, that is totally up to you. But by default, it is up. Okay. So right now, what exactly we can do is we can send a ping to our gateway. That is your router to 196.1.1, and we should be able to ping. And success rate is 80%. So right now you can see that from your multi switch, you are doing the ping. Okay. So this particular ping here is the result, and you are getting 80% success. For the very first time you are pinging, always you get the support. So on router 2, what exactly we can do? Okay. Our main objective over here is this. That from this machine, okay, from VLAN 200 and VLAN 300, we should be able to communicate with our gate, with our router 2. Okay, so this is the router address 196.1.1. When we are pinging from 194 and 195, we should be having communication, okay, to this network. And that is the reason we are performing routing. Okay, so what exactly we do is we'll configure RIP everywhere. If you want to configure EIGRP or SPF, you can basically do that. But we are going to be configuring RIP in route 2 and similarly in multi-layer switch. Now this is why exactly we're using multi-layer switch, everyone. Okay, see the functionalities what your multi-layer switch is providing you. Okay, you can perform routing, you can like but perform DHCP configurations on your router. Okay, or this is your multi-layer switch in this case, and very like what very flexible. Okay, you are having the configurations in terms of multi-layer switches. So how exactly we can do this? First of all, let's check the routing table. how many routes we have? So route by default we have how many connected networks? 3 networks, right?
Yes, three
2
connection.
is connected via VLAN 200 and 300, and 1 is connected via directly to first signal 063. So these 2 networks we are going to be dating. Okay, these 3 networks. Router IP version is 2, network is 194.1.1.0, then 195, 195, then 196. That's it. Lastly, node summary. That's it. So this is the configuration what you have done over here. And let's go to router 2. And over here, router 3. This one is only having only one network connected, which is your 196 network. So we're simply just saying 196, 1.0, they are not somebody. So right now you should be able to see this VLAN 200 and 300 network is coming to router 2 via multi switch with the help of RI. So 2 routes you should be able to see. Show IP route. And you can see the 2 routes, right? This is your VLAN 200, correct?
Yes. Yes, sir.
VLAN 200 network. And this one is VLAN
Yeah, 300.
300, right?
300. Yes, sir.
And one network is directly connected. So both this VLAN 200 and 300 network information we are getting it via RIP, right? And we are getting it via who? Via see that next hop address is what? 196.1.1.2, right?
Yes, yes,
And
sir.
this is our what?
Multi-layer
Multi-layer switch, right?
switch.
So see that how exactly your multi-layer switch is performing routing over here. With the help of this routing, our VLAN 200 and 300 machines should be able to communicate to router 2 in 196 network. And this is why exactly we are using the ping command. Can you see replies coming?
Yes, sir. Yes, sir.
And similarly from VLAN 300 machine also we are checking. So ping is 196.1.1 and communication is there. If we are doing trace search from our VLAN 200 or 300 machine, then first of all, trace search result will be what? It will be first going on VLAN 200 machine. It will be going to 194.1.1.54, and after that it will be forwarded to this router 2 via this port, right?
Yes.
By this port it will be coming to this. So this is the result what exactly we should expect from the trace set. So let's do the same ping test over here. So trace set 196 1.1, and we are getting the same result. This is your VLAN 200 gateway, and VLAN 200 gateway is forwarding the traffic to 196 network. This is what you are having, everyone. This is the layer 3 configurations. So this particular configuration is your layer 3. Okay, this is from a different topology, different uh, network topology what we have. But the configurations what we have done in our multi switches, you guys have understood, right? All of you got it?
Yes, sir.
All these configurations.
Yes.
The thing is this command, everyone. Other than everything is same. The way you are configuring RAP in your router. Okay, the same thing you are also doing it over here. Command wise, there is no change. Okay, the way you are configuring an IP address to a router port, you are also doing the same configuration in your switch port as well. The thing is this one. This one makes a differentiation. If you don't convert your layer 2 port to a layer 3 port, then you cannot basically assign an IP address directly to this physical port. This is a physical port. What exactly is available on your switch, and it is working at the layer 2 level. And since it is working at the layer 2 level, it doesn't support the IP information. And that is the reason we are converting it to this particular layer 3 port. However, if you want to convert back this layer 3 port to layer 2 port, you simply just give switch port. If you simply just give switch port command, then this port again will be converted from layer 3 to layer 2. Understood? All of you got it?
Yes, sir.
Yes, sir.
Sir, one
Okay.
question I'm having, sir.
Tell me.
Sir, like you said that by default, all the ports of the switch belong to VLAN 1, correct?
That is correct.
So when we are dividing our switch into multiple broadcast domain, so like we use VLAN 200, 300. So in the background, it is configured that we when we are saying VLAN 200, so that many switch ports will be registered for this VLAN, and for VLAN 3, that many ports are registered for.
Yes, you are doing the configuration by yourself, right? You are assigning the ports to the VLAN, right? When you assign the port to a certain VLAN, at the time that port is registered under the VLAN. Okay, and no matter how many number of machines, if I have more machines, okay, let's say that I have one more machine over here, one more machine over here, all these machines belongs to VLAN 200. So this is the port voice. I will be doing the configuration. If I connect FS0/3 over here, then I will go to the FS0/3 and I will give the same command, switch port mod access VLAN 200. That's it.
Okay.
Okay, because this is how you are assigning the VLAN to the ports. VLAN membership always is given to the port using this particular command, switch port mod access, then switch port access VLAN ID. Okay, this is the way you are configuring. Okay, for example, let me just connect another machine over here. Just hold on. Let me connect another machine. So let's say that this machine F0/3 is connected to F0/ whatever port you are connected. Okay, let's say that it is connected to gigabit 0/1. Gigabit 0/1 means what? You have on this port, you are having around 1000 Mbps speed. 1000 Mbps. Transmission reception of your frame, it is done at 1000 Mbps, that is your 1 Gbps. Okay, 1 GB per second. This particular port, okay, can transmit or receive frame. So this type of ports you basically get it at a very limited number. Okay, the 2 gigabit Ethernet ports. So if I want to configure this particular machine, okay, what exactly I need to do is I basically go to our multi-disk switch and I say interface gig 0/1 and I say switch port mode is access and we say switch port access VLAN 200. That's it. And this port is right now part of VLAN 200. And these two machines will be able to communicate with each other. Since it's a
Okay.
DHCP server, right? This
Yes,
one
sir.
is a DHCP server, right? We have configured it.
Yes, sir. Yes,
So
sir.
this machine also will be getting an IP address from this network.
This range. Yes.
Okay. So simply just we have to request for it. That's it. So let's request for an IP address. Wait for this port to become green. Automatically it will be green. And after that we'll request an IP address. So simply just request an address. You should be getting, see that 194, 102, and we should be able to make communication from this machine to 196.1.1. It's happening, right?
Yes, sir.
Yes. Okay, so you can have hundreds of machines. Okay.
Okay.
You can
Yes.
have hundreds of machines in a particular VLAN. Okay, 100 machines. But when it comes to VLAN configuration, okay, of these machines, you are basically doing the same two commands: switch port mode access, switch port access VLAN, like but 200, like that. Okay, so always you are doing it like this. Like confusion is clear now.
Yes, sir.
Yes.
So couple of things we have done, everyone. Are you guys getting confused? about all these configurations. There's a couple of topics we have discussed. First of all, the VLAN config, the VLAN concept itself. What is VLAN? Then after that, the default VLANs, broadcast domain concept. Then the configuration. How do you create your VLAN? How do you name it? How do you assign it to ports? How do you configure inter-VLAN routing? Okay. Then how to activate routing in your multi-day switch. Then how to configure your multi-day switch as a DHCP server. Then how to configure your multi-day switch to perform routing with the help of a routing protocol. That was all of you comfortable, right?
Yes, sir.
Okay. Okay, so now we are moving on to the next diagram, everyone. This is another topology for you to understand the types of link supports what we are having in switching. So these are what access and trunk. You can see that this is a topology. Okay, what we are using to understand this concept. All this. In this particular topology, you can see that we have one machine. We have one machine which belongs to VLAN number 150. Another machine belongs to VLAN number 250. One server, which is a web server, which is belonging to VLAN 500. And this is the DNS server, which basically belongs to VLAN number 1. This is the default VLAN. Okay. Now, in some cases, you are seeing I have written access link. In some cases, you have seen that I'm using trunk link. What are all these things? What are these access links? What are these trunk links? Okay. First of all, when you connect to one device, when you are connecting one device with another device, this link, okay, this connection, what you are doing, like what physically over a cable, this is what we are considering a link. It's a link. Every single device which is connected in this manner, these are considered as links. Now, all these links, it can be either access links or trunk links, okay, in terms of switches. Switches are using the ports to connect to a certain link, okay. In this particular link, the switch FS0/6 is connected. In this link, switch FS0/18 is connected. In this link, switches FS0/17 is connected, okay. So all the ports or links in your switching, okay, either it can be access or trunk. In other words, switch can either have an access port or a trunk port, or can either have a access link or a trunk link. Okay. So what exactly is an access link? First of all, whenever we are talking from this machine's perspective, on this link, whenever VLAN 150 is sending anything or receiving anything, it is always VLAN 150 informations only it is receiving, right? Yes or no?
Yes, sir.
Whenever from this laptop 3 is sending something to any other machine, it is going from what? It is going from VLAN 150. And if any machine is sending anything to this particular machine, then it is coming to VLAN 150, right? Yes or no?
Yes, sir.
Yes.
This is a single VLAN, right?
Yes, sir.
Yes.
It's a single VLAN traffic, what we are having in this link. Okay. So single VLAN traffic means what? Means on this particular link, only one VLAN traffic is moving. Okay, so from this way it is moving, or in this way it is coming. It is always VLAN 150 traffic. Okay, so when we have a single link and we are sending and receiving traffic only from one VLAN. This is what exactly the type of links what we refer as an access. Okay. This is the access link what actually we are referring. Every single time when you connect your machine to a switch of the APC laptop, always these links are considered as an access link because on these links only one VLAN traffic is allowed. Either to go from this direction to this direction or like what, or from this direction to this direction. Always this one VLAN traffic is allowed. Okay, but consider this particular situation where we have a web server in VLAN number 500. Since we are client machines, always we access servers. Okay, because we need information. So traffic from VLAN 150 and VLAN 250, it is coming to this particular switch and it is going in this direction to this particular server. Now we are having a single link, right? This is a single link, yes or no?
Yes, sir.
It's a single link, but we have what? How many VLANs traffic we are sending by the single link?
Two villain.
Two VLANs. Okay, so whenever you have multiple VLANs traffic, you need to send over a single link. At the time, we consider that link as what?
Trunk link.
Trunk link. Trunk link is very simple concept, everyone. Whenever you have one link, okay, and you need to send multiple, like more than 1 billion traffic over that link, at the time always configure that link as a trunk link. Okay, and this type of situation is the most ideal situation where when we have a server and multiple machines are accessing this server. Okay, because both these machines belongs to different VLANs and their informations are getting sent by the same link to the server. So whenever any particular VLAN or whenever any particular link is used to send multiple VLANs traffic, then that link is always referred to as trunk link. Okay. However, when we are using access link, it means what? On this single link, always we can send 1 billion traffic or we can receive 1 billion traffic. Okay. So whatever traffic we are sending or receiving, it is like what? It is for 1 billion, single billion. Okay. So most of the time when department machines are connected, okay, to switches, then these links are considered access link. Whenever they're connecting their servers, their printers, their scanners to this type of switches, then they're considered these links as a trunk link. And configuration wise, very simple configuration, everyone. Okay, what you are doing to make a trunk link in a layer 2 switch. If I show you the notepad over here, is the switching config, I guess. Let me load this configuration, switching config. If I show you this command, this is the command, right? Can you
Yes,
see
sir.
this command we are giving everywhere?
Which one? Yes, sir.
So this particular command configures these ports as what? Access. Okay, these ports are right now configured to take informations from one VLAN only and receive informations for one VLAN only, single VLAN. Okay, so these ports will not be able to receive or send multiple VLANs traffic over that link, okay, in which it is getting connected. That is the reason we are configuring this thing as an access point, because this is where exactly our VLAN 200, 300 laptop, desktop machines are getting connected.
Yes, sir.
But if I want to configure this link as a trunk link, then there is only one modification we have to do. Instead of access, I need to give what?
Trunk.
Trunk. That's it. This is the only one command. Remember, it's an L2 switch. Okay. For an L2 switch, always you do this command. Okay. You simply just say switch mode or trunk mode. But in a layer 3 switch, okay, multi-layer switch, this command will not work. Okay, if you want to see, let me just show you this. So let me just configure this particular port everyone. I'm going to configure FS0/1 port as a trunk port and FS0/17 as a trunk port. Okay, so these both these switches are layer 2 switches, L2 switch. So this command, what exactly I have shown you, it will work fine in these two switches without any problem. Okay, so let me just go to this switch. This is your switch number 6, F0/1. So let's change the host name switch 6, and the port number is F0/1, and we're saying switch port mode is strong. Okay. Now you can see that I have configured this particular port as a trunk. Okay. And this port F0/2 switch 7. It's F0/2. See that? Okay. These two ports right now are configured in these two switches as trunk ports. The thing is, whenever you configure, okay, trunk configurations on your layer 2 switches, this command will do fine without any problem. Okay. But the same command, it will not work in a layer 3 switch. Okay. For example, if you are configuring this, it's the same configuration in the layer 3 switch. So let me just connect this port on the switch. So this is your multi-layer switch now, L3, L3. So if I go to F0/2 and F0/2 and give the same command, this port is right now getting configured as trunk. However, if I go to F0/1 of this particular switch, use MLS2, multi-layer switch 2, interface F0/1, and if I simply just paste this command, you'll see it's not working. So what exactly error message you are getting is a command rejected error message. So command wise there is nothing wrong. Command is like what? Absolutely it is correct.
To convert to layer 2 switch.
Why exactly this command is getting rejected? It is because of the reason that when we are configuring trunk links, okay, when we configure trunk links, always there is encapsulation what exactly needs to set up. Okay. You need to configure encapsulation. These are the two encapsulations, okay, what we use on the trunk links. That is, one is for like what open standard, and one is for proprietary. There is your Cisco proprietary IEEE 802.1q. Open standard, in short we call it .1q. And inter-switch links, that is your ISO Cisco proprietary encapsulation protocol. Why this encapsulation is required on a trunk link? Because we are sending multiple VLANs traffic. Okay, the switch is sending multiple VLANs traffic over a single link. That is why it needs to be encapsulated with the proper VLAN information, so that our machines on the other side, they can understand that from which VLAN it is coming and to which VLAN it should be delivered. Okay. So for example, if VLAN 150 is sending a frame, okay, the frame is coming from VLAN 150, then this frame, it needs to be encapsulated with VLAN 150. Okay, information. Okay. So this is the source VLAN. Okay, this is the source, because this is the machine which is sending this information. Now to which VLAN it is going? To VLAN 500 it is going. So the destination VLAN also should be there. So that is your VLAN 500. Okay, so this is the destination. However, if at the same time, if VLAN 250 is also sending a frame, then this VLAN frame should contain the information about VLAN 250. So source is 250 right now. Okay, as a source, and that is your VLAN 500, which is the destination. So why exactly these frames they need to be encapsulated? It is basically for this for the devices which is basically connected. Like in this circumstance, this is a DNS server. You can see the DNS server is connected not directly to this particular switch, but to this switch over here. Okay, so whenever you are sending anything to this DNS server, at the time it needs to pass from this switch to this switch, then it is coming to the DNS server. Okay, so all these switches they need to understand that from which particular VLAN the information is coming, the frame is coming to which VLAN they have to deliver the frame. This is why exactly encapsulation is required. Okay, and this is the encapsulation IEEE, which is very popular. ISL not that popular because it's a proprietary one. Means this switch and this switch, it must be Cisco only. At the time only you can do encapsulation, otherwise not. And this IEEE is telling you that if it is a Cisco switch, if it is a Cisco switch, and if it is a Juniper switch, then also you can perform trunk encapsulation on this link over here. Okay, because that is open standard. This is the reason this particular error is coming up on. Okay, because by default your L2 switches, all these L2 switch, their trunk encapsulation is by default set to IEEE 802.12. Okay. This is the 802.1. This is the encapsulation by default they use this. So every single frame what they're sending, they're using this encapsulation protocol to send it. 2.12. But this type of switches, here we can define that what encapsulation we want to use, whether we want to use this one or this one. Multi-thread switches allows you to choose the type of encapsulation what you want to run on your trunk links or what you want to use on your trunk links. And by default, it is not set. That is why exactly this multi-thread switch, okay, is giving you this command rejected error. Command rejected. Okay, so command wise there is nothing wrong in the command. Okay, but the thing is, unless you are defining which trunk encapsulation protocol you want to use on your multi-thread switch on this particular port, your multi-thread switch will never perform trunking on this links. Okay, so that is why exactly it is always required. So what exactly we can do over here, we can specify IEEE 802.1 encapsulation protocol. Okay, but before configuring that, let me just do the verification. We already have configured trunk links in between these two switches. So if I simply just give over here, okay, this command, this is the command show interface trunk. Can you see that in both ports 0/1 and 0/2 we are using encapsulation? This is the open standard one, right? Yes or no?
Yes, sir.
This is the open standard. Open standard. And this is the default encapsulation. Okay, means you don't have to configure. Okay, default encapsulation. Okay, so default encapsulation which is used by all your L2 switches is what? 802.1q. This is the default encapsulation. Okay. In other words, we call it dot one q. Dot one q. Okay. This is the dot from this section dot one q. But your multi switch by default doesn't use this. Okay, that is the reason we have to specifically go to interface F0/1 and we have to say switch port trunk encapsulation one. So this is how you are manually setting up the trunk encapsulation to get one queue in a port of your material switch. So once you give this command, if I simply just paste the same command again, switch promote trunk, right now you will not see any error. And this port is right now configured as trunk port. So if I give the same command, yes, exit, show interface trunk. Can you see? Encapsulation
Yes,
is
sir.
right now .1k.
Yes.
And the mode is on, status is trunking, and F0/1. Okay, this is a port which is configured as trunk. So this is what exactly is the command. Okay, just one command. What you need to give extra on your vertical switch, apart from the same command what you were typing on your left switch to configure the trunk port. Got it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so these are basically configurations what you are having over here. So in the organization, you are going to see this type of switching network, everyone. This type of network you are going to see in the organization, where we have multiple switches getting connected to servers, getting connected to systems. One is basically doing the administration. Senior engineers are working, okay, with their systems. Admins are there. Okay, this is the environment. What exactly you are going to see in the organization. This is a switching network. If you want, you can simply just take a screenshot of this. Taken?
Yes, sir.
Yes. Yes, sir.
Sir, one question, sir.
Tell me.
Sir, means like you said that when the planes are getting transferred from one LAN to another LAN, so LAN this LAN sorry virtual LAN name is getting number is getting associated, correct?
That is correct.
But sir, like in layer 2 header, already the source and destination MAC address will be present, which
That
used
is
to be unique.
MAC information.
MAC.
That is one part of your layer 2 header. Your layer
Yes,
2
sir.
header is not about just source MAC and destination MAC. It contains lots of information. One of the information is MAC information. Another information is VLAN information. Get my point?
Okay, sir.
Think of it like this. That your layer 2 header, okay, your layer 2 header is like this particular box. In this box, you get lots of informations. So in one section, you are getting your MAC information. In another section, you are getting what? Your VLAN information. Getting my point. This entire thing is your layer 2 header, which is getting attached to your thing. Understood?
But sir, if you already have means I'm just asking, if we already have MAC information by which we can uniquely identify the device in a local area network, uh, then
In
why
a
this?
local area network, you
No,
are
not sorry.
identifying. In a local area network itself, you are identifying. But first of all, when we are using the VLAN concept, that entire LAN concept is getting divided in broadcast domains, right?
Yes, sir.
So first of all, we have to identify to which broadcast domain we have to deliver the information, right? Yes or no?
Yes, sir.
If we have, for example, if we are having one broadcast domain over here, another broadcast domain over here, another broadcast domain over here, another broadcast domain over here, and we have a switch which is connecting all these broadcast domains. So it is also connected like this, in this manner.
Got it, sir. Yes.
Right.
Yes, sir. I got
So
it.
if we are having one machine over here, machines, they are getting identified within a LAN. But the question is, how do you identify the broadcast domains? For example, if this machine is sending, okay, if this machine is sending anything to the switch, which should be delivered to this particular broadcast domain, then this broadcast domain, first of all, we have to identify that in the switch.
Yes, sir.
Once we identify that it is this broadcast domain, then we have to identify that what is the MAC address of this machine to which we have to deliver the packet. Getting my
Right.
point?
Right.
This is why source will and destination will and information are required, right?
Okay, sir. Okay. Okay. Yes.
Yes.
Thank
So
you, sir.
MAC address always we're using within a LAN. There is no doubt about that. Your communication ultimately it is done using MAC address in a LAN.
Yes, sir.
But the thing is,
VLAN we are using for reaching up to that particular network, you can say.
your switches, because when you are using this type of environment where we have
Yeah.
multiple switches getting connected to multiple departments, multiple lots of number of machines are there, then obviously whenever we are sending a frame from this machine, it is coming over here. Let's say you have VLAN 200 over here and VLAN 300 over here. So when you are sending a frame, then when it is coming to this one, then this switch must understand that from which VLAN it is coming and to which VLAN it needs to be delivered.
Yes, sir.
Right, because this
Okay.
machine can belong to a VLAN, these machines they are already belonging to VLAN 300. This switch needs to understand that. That is the reason. It's for switches understanding purpose we are creating it. Understood?
Okay. Thanks.
Okay, everyone. So this is what exactly we'll be discussing in the next session. This is your VLAN trunking protocol. Okay, we're going to be discussing this in the next session, and similarly the STP, spanning tree protocol. These are the two concepts which is left. Okay, so we'll discuss this and the cabling. If time covers, I will basically discuss this one. The cables, these cables what we are using, right? The straight through, crossover, rollover, all these console cables. We'll be discussing about that as well. Okay. So our main objective for the next session is to complete these two concepts. And if time is there, then we'll discuss about cabling as well. So just hold on, everyone. Let me just take the screenshot of this. Okay, everyone. So that will be it. We'll see you guys in the next session. Okay. Bye and take care, everyone.
Thank you, sir. Thank you, sir. Thank you. Thank you, sir.